Hi, ladies. All right, so we're moving forward today. We're going to do a little review in the beginning. You see some of my science humor here because we are working on clouds. Okay, so first, what determines what type of precipitation will fall? So, all of you answered your do now question yesterday, and you all told me that there were four types of precipitation. There's rain, sleet, snow, and hail. But how do you know which one of those is actually going to fall to the ground? What determines which one is going to fall to the ground? The answer? Anyone? Is the temperature. The temperature closer to the surface of the ground, lower in the troposphere, is what's going to determine what type of precipitation is going to fall. So let's look at this picture here. I've got a nice little field here, and up here, high in the troposphere, where we have our clouds and things, it's cold. So ice crystals form up there. The water freezes. And those ice crystals will eventually fall to the earth. We don't call them ice crystals when they're falling to earth. We call it what? Snow, exactly. So let me draw a little temperature line here. Let's pretend that at this red line, which is closer to the Earth's surface, it is 30 degrees Fahrenheit, which is cold. It's winter. It's 30 degrees Fahrenheit. So when these ice crystals up here start to fall and they cross that 30 degrees temperature line, what's going to happen to those ice crystals? Think about it. Nothing, right? They're going to fall. The temperature is still cold, so they're still frozen. So the precipitation that we will see will be snow, right? But what happens if I change that temperature line to 60 degrees Fahrenheit, like a warm spring day? As those ice crystals pass that temperature line, what's going to happen to those ice crystals? Yes, they're going to melt, and then you're going to get rain. You like my graphics? Yeah. Okay. So what about hail? Hail is different. So hail usually happens during a thunderstorm or a tornado, somewhere where you have these strong winds and you have winds pushing up. So you have these updrafts of wind, right? So I'm going to show you a little animation of hail. So if you can see here, here's a cumulonimbus cloud. It's thunderhead. And high up here, you have an ice crystal. So basically what's going to happen is it's going to fall. But then this air pushes it back up. And as it goes back up, it gets more ice wrapped around it. And it comes down, and this air pushes it back up, and more ice wraps around it. And it's going to keep doing that until it's heavy enough to fall through the wind. So here's what it looks like here. And then when it falls, you get this big piece of ice that falls on your head that hurts. And if you were looking over here, you saw that each time the ice went up, this got bigger and bigger and bigger. This is just a cross section of the ice. So here it's going down. The wind pushes it back up, and you can see it's getting bigger. And then it goes down again. The wind pushes it back up. So it just stays cold and it's like a big piece of ice. Yeah, just a big piece of ice that keeps getting bigger and bigger. And then when it's heavy enough to drop through that wind, it's going to fall and hit something. All right. So fronts and how they move. When fronts of different temperatures meet, clouds form. So yesterday we talked about cold fronts. A cold front is cold air advancing on a warm front. The water vapor cools off and forms clouds, right? We talked about a warm front, which is the opposite. A warm front is moving. a little slower than a cold front would, and it forms clouds. We talked about occluded fronts, which is 3 different air masses, a cold, a cool, and a warm, that meet and trap the air. And then we talked about a stationary front. And a stationary front is what? How does it move? Right, it doesn't. It's stationary, right? So what type of weather occurs at these fronts? For the most part, if you have a warm front or a cold front or a stationary front, you're getting some type of precipitation. Almost always, you're getting some type of precipitation. A cold front, because the cold front moves so quickly, you get stormy weather. You get big clouds, you get thunderstorms, right? For a warm front, you get precipitation, but it's a little lighter, some light rains and whatnot. I forgot to advance my slide. Here we go. So cold fronts bring cumulonimbus clouds and storms. You get heavy rains, thunderstorms, and tornadoes. Warm fronts bring clouds that yield lighter rain. Occluded fronts can be warm or cold, so they bring the same weather as a warm or cold front. So if I have a warm occluded front, that's going to bring light rain like a warm front would. If I have a cold occluded front, that's going to bring storms like a cold front would. And then you have a stationary front. That front maintains whatever weather is happening at the time. So if I have nice weather, if I'm in like a high pressure area system and it's nice weather, that stationary front is going to keep that nice weather over me until another front moves it out of the way. If I have rainy weather, that stationary front is going to keep that rainy weather over me until another front moves it out of the way. All right. Atmospheric pressure. It varies. So there are high pressure systems and low pressure systems. And how we measure the atmospheric pressure is with this instrument right here. Anybody remember the name of it? Starts with a B, and it's here, a barometer. So when you have a high pressure area, that air pressure is essentially pushing down. And what happens is the barometer goes up, and we know that there's going to be nice weather. It's going to be dry, it's going to be fair, a nice sunny day. When you have a low pressure system, the barometer goes the other way. That's when you're in for a storm, you're in for a rain. So let's talk about these low pressure systems. And remember, if I'm going too fast, just pause the video and unpause it when you're ready. So a low pressure system in the northern hemisphere, that's where we live, they go in a counterclockwise direction. They're called cyclones. Now this is on page, let's see. This would be on page 199 of your book. All right, so low pressure systems are associated with stormy weather because if you look here, we've got a warm front, we've got a cold front, they're meeting, they're swirling. The low pressure system, it's causing precipitation, so you're going to get stormy weather. A high pressure system, however, goes in the opposite direction. The high pressure system is moving clockwise, and they bring nice weather. Okay, so this is something new. Here is a map, and we have all these lines, but actually they're not lines because they're connected. They're circles. And these circles are called isobars. Iso means same, and the bar stands for barometric pressure. So the isobars connect points of equal barometric pressure or of equal air pressure. So here, let's say, every point along this circle is 1,024 millibars of pressure. every point here along this circle that we can't see the whole circle is 1,012 millibars of pressure. Every point here is 922. Every point here is 1,012, and so on. Okay? So isobars connect areas of equal pressure, of equal barometric pressure. Here's something important that we need to know about air pressure. Winds travel along these air pressure systems. Winds always move from high to low pressure areas. Always move from high to low. So here, this says 1012, this says 1006. This one is lower, so the wind would be moving from here, 1012, to here. It would be blowing this way, from 1012 to 1006. Always moves from high to low. If I'm here, 992, 1012, which one is higher? Yeah, 1012. So the wind is going to move from 1012 down to 922. So the wind will be moving this way. If you have large increases in barometric pressure, you're going to have strong winds. If you have gradual increases like 992, 993, 994, 995, you're going to have wind, but it's going to be, very light wind. If this is 992, this is 1050, this is 1070, you're going to have strong winds moving from high to low. All right, quiz yourself. So I want you to shout out the answers. I know. Nobody can hear you, but shout them out anyway. All right, here's the first one. So I'm going to read the top of the map. It says the symbols on the weather map below show the location of fronts, high and low pressure areas, and different kinds of precipitation across the United States in the afternoon on a particular day in March. The key below the map tells what the symbols mean. So there's the key. Okay, so here's your question. What type of weather is Denver, Colorado having? So here's Denver. What type of weather is Denver, Colorado having? Gonna give you about 7 seconds more. Oh, I didn't read the answers. Sunshine, rain, snow, or sleet. And the answer is snow. So here, if you look here, you see these circles. You look here, you see what it means. Next question. What type of front is near Denver, Colorado? Is it cold, warm, occluded, or a stationary front? If you said cold front, look again. The answer is in the key as well. It is a stationary front. It's not going anywhere, so it's going to be snowing over Denver for a while until another front comes and moves that out of the way. Which coast of the United States has a low pressure system? And how do you know? Which coast? The East Coast over here or the West Coast over here has a low pressure system? And how do you know? Well, I know high pressure means nice weather, and I know low pressure means stormy weather, rainy weather. So I see some rain over here, but not a lot. I see a lot of rain over here, all the way up and down the East Coast. So I'm going to say it's East Coast because low pressure systems bring rainy, stormy weather. Next question. Identify the name of the circular lines on this map. Isotherms, isocremes, Isobars or isowinds? I know iso means the same, and these particular lines connect air pressure, barometric air pressure. Isobars would be the answer. Isobars. Next, in which direction is the low pressure system moving? Is it moving north? Is it moving clockwise? Is it moving south? Or is it moving counterclockwise? Remember, low pressure systems are also called cyclones, and they move counterclockwise. In which direction is the wind blowing in the box section? Northeast, southeast, northwest, or southwest? So in this section here, which direction is the wind blowing? So remember, you're looking for the high and the low, and wind always moves from high to low. So this one is moving northeast. It's moving in this direction here. All right, from 1024 to 1012. In which direction is the wind blowing in this box section? So you can see the numbers. I highlighted the numbers for you. This one's 992. This is 1012. So which direction would it be moving in? Northeast, southeast, northwest, or southwest? Southwest. So it's moving from high here to low. It's blowing from here to here. All right. So that is today's lesson. I want you to go back as many times as you need, at least one more time, and just review the lesson today. Take your notes because you will have a quiz on this. All right, so take some notes, review precipitation, fronts, what causes, what determines what type of precipitation we're going to have, what happens at different fronts at their boundaries, barometric pressure, which way the high and the low pressure systems move, right? Which way they move, what type of weather do they bring, isobars and wind, and then go ahead and quiz yourself again. Quiz yourself until you can get 100 and know why for each question. You can explain the answer for each question. All right. Then your homework is here. I'm going to try to make it so I can give each one of you your own copy so you won't have to go to file and make a copy. You can just write right in it. So the highlighted lines, if you just double click on them, you'll be able to just write in them. So this will be your homework. It's 2 pages. You can use your book. You can use the video. For this one down here, I will create numbers and you can write the answers down below in the numbers so that everything can just be on this page and then you can submit it. All right? All right, ladies, I hope you enjoyed this video. If you have any questions for me or you need me to explain something in more detail, just email me and I will do that for you. All right. So get working and start your homework. Start filling in those pages. Oh, and also Don't forget to review this PowerPoint at least one more time and take good notes.